In this video, we're going to take a look at the roots of a quartic equation. Now let's just start by considering the following quartic equation here, where x belongs to the set of complex numbers here, and a, b, c, d, and e here are all real numbers. So as we can see then, we have this quartic equation here that is equal to 0. Now, if the roots of our quartic equation here are given as alpha, beta, gamma, and delta, then we can determine the relationship between the coefficients of the terms within our quartic equation and the values of alpha, beta, gamma, and delta. So let's take a more formal look here at this concept. So to get us started here then, we have an equation. Now, on the left-hand side of my equation here, just notice this quartic is the same quartic that we had on the previous page. On the right-hand side of my equation, what I've got here is the roots are the solutions to this quartic here if it is equal to 0. So we set this equal to 0 here, like so. And from here, I can identify the roots or the solutions to this quartic equation. So in that case, x is equal to alpha. So x is equal to alpha. My second root here, we get x equals beta. We then get x equals gamma. And then finally here, we get x equals delta. Okay. So as we mentioned then on the previous page, our four roots here to this quartic equation are alpha, beta, gamma, and delta. Okay. And the first thing that we're going to do here is expand the right-hand side. So mathematically looking at this, nothing too challenging. As you would expect, there will be quite a few terms here, right? So feel free to have a go at this and do it by hand if you want to. You don't have to. I will just give you the result here. So if you expand the right-hand side, then you should obtain the following here. So as we mentioned then, there is quite a few terms here, right? And in its current form, this isn't particularly useful. So what I want to do here then is get this into a form that is easier to work with. So what I'm going to do here then is group the x cubed terms together. I'll then group the x squared terms together. I'll then group the x terms together. And then finally at the very end, we get left with alpha, beta, gamma, delta. So if you do this correctly here and you factor it correctly, you should hopefully obtain the following here. Now, why is this form here much easier to work with? Why is this useful? Well, the reason that this is useful here is because we can now equate coefficients. So what do I mean by that? Well, for example here, just refer back to the original quartic then, I can see, for example, we've got ax to the 4 plus bx cubed plus cx squared plus dx plus e. So for example here, equating coefficients, I can see then that b is equal to minus a times alpha plus beta plus gamma plus delta. I'd do the same here for the c coefficient, or the coefficient of x squared, I should say. So that's this c here. Doing the same for the coefficient of x here, and then finally this e. So altogether then, you should obtain the following results here. So as we can see then, and as I mentioned, b is equal to minus a times alpha plus beta plus gamma plus delta. Doing the same for c here, doing the same for d, and then finally the same for e here at the very end. Okay. So that gives us more of a formal kind of definition and demonstration here of the concept that we mentioned on the previous page. So to summarize here then, if alpha, beta, gamma, and delta are the roots of the following quartic equation here, then we have the following results. So as we can see then, we have four results here. So for my first result then, we have alpha plus beta plus gamma plus delta, and that is equal to minus b over a. For my second result here, we have alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta, and that is equal to c over a. For my third result here then, we have alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta, and as we can see, that is equal to minus d over a. And then finally here, nice and straightforward, we have alpha beta gamma delta, and that is equal to e over a here. Now please do make a note of these results here. These results are really, really important. But you do also need to be aware that we can use the following alternative notation here. So what results do we have here then? Well, these results do make life a little bit easier. So what do I have here then? I've got sigma alpha, which is equal to minus b over a. And hopefully you can notice then that this result here, this number 1, corresponds to this result here, which again, I'll just highlight as number 1, just to show that these two results correspond then. For my second result here, we have sigma alpha beta, which as you can see is equal to c over a. And again, this corresponds to my second result here. So let's just highlight that as so. And then finally here, for my final result, then we have sigma alpha beta gamma, which is equal to minus d over a. And again, hopefully you've noticed that this corresponds to my third result here. Okay. It's completely up to you which of these two sets of notation you prefer to use. Either's fine, but just please do make a note of one of the following sets of notation. Okay. So there we have it. So that gives everything that we need here then for our introduction to roots of a quartic equation. Let's take a look now at one practice question. So let's just take a look then at this practice question here for the roots of a quartic equation. So as we can see then, alpha, beta, gamma, and delta are the roots of the following quartic equation here. Now as the question says then, without solving the equation, find the value of the following here. So we've got part A, part B, part C, and then finally part D here. So let's begin then with part A here. So for part A then, it asks us to find the value of alpha plus beta plus gamma plus delta here. So hopefully you recognize straight away that this result here is one of our standard results. So in that case then, this will be equal to minus b over a. Okay. So let's just refer back to the original quartic here then. So in that case, the coefficients here for this quartic are given as follows. So a is equal to 3, b is equal to 2, c is equal to 1, d is equal to minus 1, and then finally e here is equal to 4. Okay. So in that case then for part A here, this is equal to minus b over a. So in that case then we get minus 2 over 3 here. Nice and straightforward there. That gives us the solution to part A. Now for part B then, so for part B here, again, hopefully you recognize straight away that this result here is one of our standard results then. So for alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta, this result here is equal to minus d over a here. Okay. So in that case then, what do we get here for part B? Well, I get minus, so we then have d over a. So d is minus 1 over a, which is 3. So I get minus 1 over 3 here. And just be careful with the signs then. Minus over minus becomes positive, so we get 1 over 3 there. Okay, and there we have it. So that is the solution to part B. Now for part C then, not quite as straightforward as part A and part B. So for part C here, what we need is a fraction. Now we have seen similar examples for roots of a cubic and roots of a quadratic. So for this result here then, these reciprocals, what I need here is a fraction as we mentioned. So I need them. Alpha, beta, gamma. Alpha, beta, gamma. Basically what I'm looking for here is this expression, right? So that's my numerator. So alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta. So alpha, gamma, delta there. And then finally beta, gamma, delta. So beta, gamma, delta here. So that's my numerator there. Notice it's just the same expression from part B. That gives me my numerator there. We now also need our denominator here. So to obtain this result here then, okay, of this expression, what I need then is my denominator here to be alpha, beta, gamma, delta. So alpha, beta, gamma, delta here. Okay. Well, we know the value of the numerator here. We've already evaluated that. However, the denominator, we don't know the value of this just yet. But again, hopefully you recognize here that this denominator is one of our standard results. So let's make a note of this here with inside the question. So alpha, beta, gamma, delta here, that is equal then to E over A. So we get E over A here. So E is 4, A is 3, so we get 4 over 3 there. Okay. We've got everything that we need then. So my numerator, that's part B, that's 1 over 3. We get 1 over 3. And this is over then alpha, beta, gamma, delta, which as we can see then is 4 over 3. Well, in this case here, the 3's will cancel. So they'll cancel out. And we get left with 1 over 4 here. Okay. We get 1 over 4 there for the answer to part C. And then finally here for part D then, what do we have? As we can see then, we've got alpha to the power of 3, alpha cubed. We've got beta cubed. We have gamma cubed. And then finally, we have delta cubed. Okay. So to find the value of this expression here, then we just rewrite this. So this is the same then as alpha, beta, gamma, delta here, all to the power of 3 here. So nice and straightforward, just basic rules of indices. But we know the value of this expression here inside the bracket. We just evaluate that in part C. So that's 4 over 3. And this is all to the power of 3 here. Well, this is the same then as 4 cubed over 3 cubed. So 4 cubed over 3 cubed. Well, 4 cubed is 64. 3 cubed is 27. We get 64 over 27 there. We can't simplify that any further. So there we have it. So that gives the solution to part D. And that gives us the solution there to this practice question. So that brings us to the end then of this video here on roots of a quartic equation.